I've created a physical model which I hope will explain why sailboats can travel faster than the wind. So look, the wind comes in from here, it pushes on the sail and it pushes the boat, we can call it a boat, can't we, in this direction here. So what is the theoretical maximum speed of this boat? Let's assume that there's no resistance. That's a ridiculous assumption, but it's useful for our understanding here. Well, the maximum speed of the boat is the speed at which the sail exactly misses the incoming air. Let me explain what I mean by that. Imagine you've got a packet of air coming in at this speed, and the boat is moving at just the right speed that the sail exactly misses that packet of air. The packet of air is unaffected by the sail at this precise speed. For completeness, here's a whole load of packets of air failing to be affected by that sail because the boat is moving at just the right speed. Actually, there's something confusing about this graphic, isn't there? I think it's sort of an optical illusion, actually. If the boat were going any slower, that packet of air would be deflected slightly, and so the boat would increase in speed until it reached that magic speed. Again, this is all assuming that there's no resistance. With the sail at 45 degrees like this, the speed of the wind and the speed of the boat are actually the same. Look, by the time that packet of air has travelled this distance, the boat has travelled this distance. They match when the sail is at 45 degrees. But what if we changed the angle of the sail so it's like this? There's actually now too much friction between my hands and the sail, so I'm going to switch to this stick with a wheel configuration. It's pretty high tech over here. So now, in the time it takes for this packet of air to move this distance, the sailboat has moved this distance. It's actually traveling faster than the wind. And remember, if the boat were going any slower than that, it would be deflecting the air and there would be a reaction force speeding the boat up. At this point, you might think, well, why don't we angle the sail so it's really, really close to the direction of travel? That way we could go much faster than the speed of the wind. Well, there's a trade-off, and you can see it here. Look, when the sail is really close to the direction of travel, the component of the lift force in that direction is really small. So it would take a long time to reach that top speed. And actually, that's only true in a world with no resistance. In a world where there is resistance, which is to say the real world, the ship wouldn't be able to get up much speed before the drag force exactly cancels out that meager component of the lift force in the forward direction. So in practical terms, there's an optimum angle for the sail, and actually that's part of the skill of being a good sailor. I can also use this model to show how it's possible to travel against the direction of the wind. But first I just want to talk about the shape of the sail compared to this model that I've used. We talked about how a sail generates lift in the same way as an aeroplane wing, and an aeroplane wing tends to have this cross-sectional shape. It doesn't have to be that shape. Planes can fly with a wing shaped like this, angled into the direction of travel. It's just that for complicated aerodynamic reasons, this is a more efficient shape. The same thing is going on between my model and real sailboats. My model is this flat surface, while sailboats act more like that curved profile of an aeroplane wing. So how can you sail into the wind? Well, you can't sail directly into the wind, but you can sail a little off from directly. I'll just show you with the model. So the wind is coming in this direction, we want to travel in this direction, we angle the sail like this, and there you go, the boat moves forwards. This isn't exactly how the sail would be positioned in reality, because in this model I'm making the force vector be in the same direction as the direction of the wind, but the vector in a real sailboat is based on the change of direction of the wind. But it's the same basic idea. Actually, you can travel directly into the wind, you just have to take a zigzag path, and that's called tacking.